Hello, welcome back to my YouTube channel. And today, I wanna explain you all about number system. Yeah, in this number system, there's the number one, two, three, and blah blah blah. This number is the most basic level concept in mathematics. Yeah, yeah, it is the most encountered problem in our life. And this sequence can be called natural number, which is symbolized as big N. And then if this sequence number pair with the number of 0, so that's the sequence form like 0, 1, 2, blah 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 from the previous sequence number, and then it can result whole number or can be symbolized as big N ASIN. And again, higher than whole number if we pair with a negative number like -1, -2, -3, and so on, paired with the whole number, it can be called integer or symbolized as Z. And again, higher than integer, yeah, there's some concept number, yeah, which is more complex rather than integer. There is rational number, or be symbolized as key. What is rational number? Rational number is the form of number which is stated as fractional number, whereas A and B, this is numerator, and B denominator, which is both A and B must be integer. Yeah, that means A and B have to be formed -3, -2, -1, blah blah blah. And B cannot be 0. Yeah, and so yeah, this is the uh, convection of integer. Yeah, that uh, the number of A and B must be integer. Yeah, this is the rule of number of rational. Yeah, and then what the example of rational number? Yeah, like 5 per 2, like 2 per 3. This is a rational number. Yeah, and again, yeah, as we can see that among of these four level, rational hold the highest, natural hold the lowest. Natural is the most basic, whereas rational is the most advanced level number of hierarchy. And again, can rational number be called integer, whole, or even natural? Yes, it's depend on the result. Yeah. As for example, yeah, if the rational is the rational the number like 6 per 2, as for example, and then we result it as 3, can Can this number not only included as rational? Yes, this number 6 per 2 can be included as lower number too, like integer, whole, or even natural. Yeah. And then there's a statement like um, minus 8 per 4. It is rational. Yes, it is rational. And then if we result this number minus 8 per 4 is equal minus 2, this number can be called integer but not whole or even natural. Why? Because this number minus 8 per 4 gets stuck at minus 2. Yeah, whereas minus, it is not valid in whole and even natural number. Yeah, and so yeah, this number minus 8 per 4, it's just stuck at the integer level. Yeah. And again, yeah, like, and then 5 per 2 and 2 per 3. This number can be called integer or even natural or even lower number. No, exactly. Why? Because this number is fractional. Whereas integer, whole, and natural is the form of unity number. Yeah, I mean full number. Yeah, full number addition and not fraction one. Yeah, so that this number like 5 per 2 and 2 per 3 can be classified as integer, whole, or even natural number. Again, what is the other classification rather than rational? Yes, there's the other classification, but not higher level. What's the kind of the level is? Yeah, the level is, yeah. Previously, we have discussed rational number. Yeah, exactly here. If we zoom out, yeah, the scheme, we symbolize it as a key, a big key, yeah. And then beside rational, there's irrational, or we symbolize it as key agent. What is irrational? Irrational is the number where can be stated exactly, yeah, or officially as a per b. Yeah, yeah. If previously rational can be stated as a per b exactly, but irrational can't. Yeah. What is the example of irrational number? Irrational number, as for example, like the square root of 2 and pi. Yeah, the square root of 2 is 1.1412 blah blah blah. And p 3.1495 blah blah blah. Yeah. This number where the point goes on forever, but it is not having regular pattern. What is regular pattern? Yeah, we will discuss it further. Yeah. We will discuss it further like this. Yeah. Again, to classify them as whether this number can be rational or irrational, it's depend on the result, yeah, from the fraction. Suppose if the result can be 10 per 5 and then its result 2, this is still rational, right? Not irrational. Because this number can be stated as this fraction, 10 per 5, and maybe this is can be convert to be 2 per 1, 4 per 2, blah blah blah. This is rational number. And again, if the number supposed to be 15 per 2, this is resulting 7.5. This is still rational? Yes, this is still rational because this number 15 per 2 can be converted as 30 per 4 and then blah blah blah. And again, there's result if some fraction can result in 3.33 bar, like here. Can this number be classified as rational? Okay, let's see. This number is the different one rather than these two previous result number. As we can see that this number so different rather than the other because there's bar. Yeah, there's new concept number. If we convert to the number 3.33 bar to be 3.3333 blah 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 blah. As we can see, yeah, despite this point, of number goes on forever, but this pattern still same, remain the same. 3 blah 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 blah. And because of that, yeah, this number can be classified as rational. Yeah. Yeah, because this number can be converted as rational number, which we will discuss it on the next video. Yeah. So for now, we just discuss about the introduction of concept to classify this number. Yeah. And again, there's the other number. Like, as for example, if suppose we meet 34545 bar, it is still rational. If we expand this number 3.4545 bar, it can be expand like 345454545 blah blah blah. And again, if we see this point goes on forever. But look, this number still having the same pattern. 45, 45, 45, 45, blah blah blah. And this pattern is regular, 45. And then we classify it as rational number. And again, what if what is if 12.810708 bar? This is the I feel like this is the very different one, because this decimal number so far. But however, it still retain the same pattern, right? It is still regular. Like here, 810708, 810708 and blah blah blah. It still remain the same regular pattern. Yeah, regardless how long this digit. Yeah, and regardless how long this unit place number. Yeah, this is 12. Yeah, greater rather than 9. Yeah, there's 10 place. Yeah, and then this number is still classified as rational number. Yeah, no matter whether it is 12, 100, feel like I say 1888, yeah, or 1,075,000 blah blah blah. Yeah, this number is still considered, yeah, as rational. Yeah, as long as this pattern still remain regular. Okay, and then lastly, what if the number, if we encounter like 7,448 to 1,300,708, blah 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 blah. Can we classify this as a rational again? Look, this number, yeah, as we can see, it is right that this point goes on forever. But this number, yeah, as we can see, it has irregular pattern. Yeah, 448213000708. Blah, and this blah blah blah, we don't know what's the next of this number. Yeah, like we say, yeah, P, yeah, 3114159 blah 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 blah. It is still irregular pattern. Yeah, and then the square root of 2, it is 1.1412 blah 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 blah. We don't know exactly what the behind of this blah blah blah, and we don't know the blah 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 is, and the pattern is irregular. Yeah, and so this number can be classified as irrational. That's why on the previous video, yeah, on the previous minute, yeah, I have been explaining you all why irrational number can be included as p or square root of 2 because of this reason. Yeah. Again, beside irrational, if suppose we meet the irregular pattern like before, but nothing have blah 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 like here. 4.4108227381. Oh, this is so long, right? And it has irregular pattern if we see. But as you can see that this point ain't goes on forever. It is still handed to this number 1. Yeah. And we can transform it as fraction. Yeah, fraction which I explained like a per b. Yeah, if we expand, it can be 44108227381 per 10 powered to 4698. Oh, again, 2 4 6 8 10 10 10 powered 10. And this because this number can be formed like a per b, whereas b mustn't be 0, and then this number a and b have to be uh, irre- um, has to be integer, yeah, I mean integer, yeah. And so this number can be classified as rational. This number, yeah, because this number can be converted to fraction like here. Yeah, regardless um uh how long this number, yeah, behind the comma, yeah, behind the point, yeah, I must say. And then again, yeah, after we see the previous example, we can determine it as rational and irrational, yeah, by point, yeah, and the regular pattern of behind the point, yeah. Okay, beside there's rational, we have discussed rational, and then this is one irrational, and then there's the other one. Yes, there's the other one that is imaginary number, or we symbolize it as I. What is imaginary number? Imaginary number, yeah, is the number which is where the number form the square root of negative real number. Yeah, I mean like the square root of negative 5, the square root of negative 13, the square root of negative 13 point 8, and so on. Ya, the main point ya negative number lah. Ya, a negative number inside the square root. Ya. Anyway, there's still debate, yeah, whether this number can be solved or not, yeah, because yeah, I mostly found, yeah, in the real life that this number can be solved. Yeah, this number error, yeah, if we put the calculator, yeah, and then this number can be defined, and then this number can be translated as I, yeah. As for example, if we find the square root of negative 7 can be stated as 7I, yeah, and blah blah blah. But however, because there's so much debate which can be stated determinately, so we can discuss it further, the imaginary number, up to this lesson. Yeah, up to the lesson, yeah, to the next lesson, yeah, we just ignore this concept imaginary, because as for myself, there is still debate. Yeah, so yeah, for the next lesson, we will use rational and irrational number, which is if combined, this number can be formed real, or we symbolize it as big R, whereas imaginary can be called non-real. And again, yeah, real number most often find, yeah, in our life, yeah, like calculating in engineering or even economics and so on. Yeah, yeah. If we use this number wisely, yeah, we can translate it as the powerful weapon, yeah, to yeah, for our world. Yeah, so yeah, hopefully, yeah, may you can understand this concept first. Yeah, rational, irrational, real. And this, because yeah, this is the uh, most common use to solve the problem, whereas imaginary is very rare. Yeah, if it is happen, it is very rare. Yeah, it can be ignored. Inside rational, there's integer, yeah, like here, and then inside integer there's a whole number, and then the most inside is natural whole, and then this is integer. Yeah, this is integer, yeah, inside rational. This is whole, and then this is the deepest one, natural number. So that this is the number system concept. I wanna explain you all about it, so that uh, it can be useful for us, yeah, by discussing this number concept. Yeah. For the next video, I will explain you all about example number and the quiz. Yeah, so that it can be strengthen your understanding about this number system. Okay, thank you for watching. Don't forget like, subscribe, and share this video so that yeah it can be useful not only for us but also it can be useful for the other. Thank you for watching and see you next time.